Hello, everyone. Welcome to my poster. My name is Xuan Ren. We know that educated adults have access to two different systems to represent numerical information: an exact number system (ENS) that relies on different forms of number symbols, and an approximate number system (ANS) that allows for approximate estimates of numerical quantities. However, previous research has yielded mixed results regarding the extent to which these systems are integrated in adulthood. For example, the distance or visual effects observed in symbolic and non-symbolic tasks have been taken as evidence for the integration between the ENS and the ANS. However, Lyons and colleagues show that additional cognitive effort was needed in a mixed format condition, likely due to a lack of integration between non-symbolic and symbolic number representations. Moreover, Lyons and colleagues used a numberless task and found that human brain can readily integrate non-symbolic and symbolic number representations, even in the absence of a task that requires numerical judgments. Besides those uncertainties in the literature regarding the integration between ENS and ANS, it also remains unclear how this numerical integration relates to adults' formal math abilities. Therefore, the goal of our study was twofold. First, to determine whether evidence for numerical integration is task-dependent, and second, to explore the relation between numerical integration and adults' math abilities using different measures of numerical integration than in previous studies. 115 adult participants were in our study. Participants from math abilities were acquired using Woodcock-Johnson tests, consisting of 3 subtests. In the number comparison task, which has 4 conditions, participants were required to decide which one of the 2 sequentially presented stimuli was numerically larger. Since explicitly asking participants to compare 2 formats of number may force them to translate the symbolic number representation into non-symbolic ones or vice versa, we implemented a numberless task that did not require explicit judgments about the numerical information to tap into implicit numerical integration. We first measured participants with non-symbolic estimation biases using a dot estimation task, and then generated the stimulus sets for the numberless task for each participant based on their estimation biases. In the numberless task, participants were instructed to judge whether each stimulus contained a replicating numeral or a letter pair. You can see it here. In the number comparison task, we found that participants were significantly slower when comparing mixed format stimuli compared to the same format stimuli, regardless whether those are dots or numerals, which suggested that different formats are not immediately integrated. Within the mixed format stimuli, participants were significantly slower when Arabic numerals were presented first and the dot array second, compared to the opposite order, suggesting that the order in which different formats are presented has an additional impact on the integration between different numerical stimuli. In contrast, in the numberless task, participants were significantly faster in number judgments when the dot arrays matched the Arabic numeral, suggesting that task-irrelevant numerical information embedded in the dot arrays affected a simple number judgment. To investigate the numerical integration across symbolic and non-symbolic number stimuli in the number comparison and the numberless tasks, we first calculated indices of numerical integration for each task. For number comparison tasks, we calculate the mean difference, the mean response time difference between each of the 2 mixed format conditions and the same format conditions. And for the numberless task, we calculated the mean response time difference between mismatch and matched trials for the numeral condition. Pearson correlations were conducted between the indices for those 2 tasks. No significant correlation were observed between number comparison and the numberless task performances. We also correlated the same indices of numerical integration derived from the number comparison task with the Woodcock-Johnson composite. We found that numerical integration derived from the number comparison task significantly correlated with the adults' math abilities. Therefore, we conclude that numerical integration is task-dependent, and that some of these processes are related to adults' formal math abilities. Thank you very much. If you have any questions, please shoot my email. I'm happy to answer. Thank you.